All right, part two of complex numbers. Going to start it off with number 13. 13, 14, and 15, all multiplication. Could do it pencil and paper, but I would be real foolish because the calculator is definitely the way to go with multiplication, and then I'll talk about the division in a moment. Number 13, so it's quantity 3 minus 3i, close parenthesis, times, I don't need a time symbol. Well, I do need parentheses though. So there's a parenthesis and 4 plus 6i. 4 plus 6. Second function, the period key. And 6 is mouse. Whatever, blame it on the mouse. 30 plus 6i, not a problem. Just me entering those values. And I guess that was a hard part. Anyways, let us see. So clearing this off, you can see where this is definitely the way to go. I wouldn't even, would I want to foil this out? Yeah, we could. Then again, I could, if you want some sandpaper, I guess, too. So we'll take the way of least resistance. 8 plus 4i. Close the parenthesis. We got it written right where this is. 32 plus 56i, letter C. And this last one with multiplication. 9 plus 6i. Close parenthesis times 7 minus 6i. And close the parenthesis up. Hopefully it's written correctly. 99 minus 12i, letter 50. All right, so you can see multiplication doesn't get much simpler. Here's the deal with number 16 and 17. All right, shouldn't have put it on here. Reason being, in class, seriously, it would take me a good 6 to 7 minutes to do each one of those. You're looking at about 15 or 20 minutes just to do it. And yeah, could I do it? No doubt. Would I ask you to do it? The reason being is that, I want to do number 18 with a calculator, but 16 and 17 have radicals in them, both in the numerator. All right. And it gets to be all that in a bag of chips. So chances are, no, I wouldn't give you one like this on the exam. You're all kind of wondering. Maybe I'll give it to the woman, not the men. But anyways, no, I'll at some point in time I will do these two out. I'll upload a video. I know some of you are going to challenge yourself, and rightly so. I mean, that's I appreciate that. That's great. But for right now, I'm not going to try to be a hero here and do these because it's just not worth the effort. Not worth the time. Time is precious right now to a certain extent. As far as all right, number 18. I'm dividing, so I need to put this numerator in parentheses. 2 plus I. The reason I'm doing this is with a calculator is that because 2. All right, let's go. 2 plus I. Lost my train of thought. Oh, the reason I'm doing this on a calculator is that there's no radicals like 15, 16, and 17. So this should come out fairly good if I can put a divide sign. And in parentheses, the denominator, -4 and minus 8. Close parenthesis. And I got no decimal places. 0 plus 0. All right, so when that happens, let me go and set this at, just to be safe, 3 places. I'm glad that happened, actually. All right, so what do you get? A negative 2.00 plus 0.15, sorry, 0.150i. Now, you know it's not letter B, and chances are it's not letter D. I think about this, this looks like 1/5 to me, and that looks like 3/20. But yeah, okay, I have I don't know the right answer. So let me do this. Let me go to math, go to fraction, hit fraction, and once again the calculator bails me out. And the reason it happened, and it wouldn't. That's why I didn't do 16 and 17 because that wouldn't have happened. You had radicals. But when you don't have radicals, if you get decimal representation, you can always go to that math key, hit fraction, and that worked out rather well for us. So hopefully my voice isn't fading off. All right, number 19, I to the fourth. I is weird in that it repeats itself. I to the first is I to the second, by definition, is -1. I to the third is negative I, and I to the fourth is +1. Then it repeats itself. I to the fifth is the same thing as I to the sixth is like I squared negative I to the seventh, and so forth. So I to the fourth, hey, I know that's by definition +1. Now I to the 21st power. Since this complex number, by definition, repeats itself every singularity, every 4 times it repeats itself. What I tell students to do, take the number, the exponent of 21, divide it by 4. So it's going to repeat itself 5 times. 5 times 4 is 20. 21 minus 20 is 1. All right, so the answer is I to the first power, 1 power, which is I. If you want to try your calculator, here's what you do. All right, you go second function I, and you raise this to the 21st power. Watch what happens. You get this weird number here. You get it's actually you're going to either see a plus, a weird number, and something to do with I, or I and some weird number at the end. I'm looking for either the plus or the minus sign. In this case here, it's the plus sign. All right. So that tells me this nonsense here, this e to the -13, doesn't make any sense. The calculator has an issue working with the letter I. There's always going to be some funky part. You got to ignore the funky part, and the part you're looking for is the letter I, which we talked about a moment ago. I to the 14th, 4 goes into 14 3 whole times, 3 4s are 12, 14 subtract 12 is 2. The answer is I to the 2 power. I to the 2 power, second power, is defined as -1. But you're insistent on using the calculator, so you go second function I, and you raise it. You raise it with this little caret key, you raise it to the 14th power. Once again, you get this crazy answer. What I'm looking for is either a plus or a minus sign. Well, there I see a minus sign. Here was a plus sign. I ignore this nonsense. Here I got a minus sign. I'm going to ignore the part that gets involved in e to some crazy negative power. This is just nonsense. Here is my answer. It's -1. Granted, I got 3 zeros, but it's still -1, which you just figured out a moment ago. So the calculator will do it, but you got to figure out what's the nonsense part. Nonsense part will either be to the left or right of a plus sign or a minus sign. Your answer is what's left. All right.